Thank you very much. Thank you for the introduction. Uh, like David has said, a graduate of computer science, founder of Gershinen Technologies. We are a data as a service provider, leveraging data and artificial intelligence to solve socio-economic problems here in Nigeria and Africa as a whole. And apologies for the delay. I had a last minute glitch on my end, but all has been sorted out. To that end, today we'll be looking at AI, the different types and algorithms that power AI. So a lot of material for artificial intelligence, what is it, machine learning, and all the rest. What are the algorithms? How many types do we have, right? And for each one of them, what are the algorithms that, how do we go about them? So I'll be sharing my screen. Let me know if you have thumbs up, you can see my screen. Yes.
Yeah, great. I can see your screen. So guys, anyone else who can see his screen, can you guys just react? So we would know you're seeing Shandon's screen. Awesome. Awesome. Beautiful.
Right. So yeah. So AI fundamentals for the curious, and if you look at the world we live in today, basically, and I like the title of this series, right? AI fundamentals for the curious, right? Because AI is transforming the way we live, the way we learn, the way we work, the way we do a lot of things, and having the knowledge of this type of systems gives you a head start in life, gives you a head start in work, gives you a head start in a lot of things. You're going into business, in your academics, in different aspects of life. AI is slowly establishing itself as a key figure. And so having this knowledge, the background knowledge, the fundamental knowledge, how it all works together, how everything comes together to work is very crucial. And today we'll be looking at that. We'll see the different types of AI that there are out there. We'll see what are algorithms, right? The learning objectives. We'll see what are algorithms. We'll see the different types of algorithms, different types of approaches to all of these problems that machine learning tends to provide solutions to, right? So without wasting much time, right? What is AI? We are here to learn about AI, the different types, the this, the that of AI. What is AI, right? Artificial intelligence, what is it? Now, John McCarthy, who is considered one of the fathers of artificial intelligence, simply defined artificial intelligence as the science and engineering of making intelligent machines. Now, it is simple, but it's quite broad, right? Now, a more modern definition of this same term, AI, will be something like a broad branch of computer science, right? That is concerned with creating machines that can learn, that can make decisions, and perform tasks to human-like level, right? We want machines that can learn, that can carry out tasks. Very important, make decisions to the level in which we expect a human to make such tasks, right? So the goal is to have machines that can learn, machines that can grow on their own, independent of human intervention, right? And when that happens, we then have machines that can carry out complex tasks, and whatever the task is, whether it's trading, whether it's teaching, whether it's creating a curated material, whatever it is, we have these systems that have learned, that have grown, that have mastered these skills, and now they can deliver this without human intervention. And that's essentially what an AI, what an artificial intelligence is. Now, next on our list, we'd like to look at how many types of artificial intelligence, right? So we've already seen that, yes, AI is this, the art, science of creating intelligent machines. How many types of AI do we have, right? Basically, there are 4 types of AI, right? We have the reactive AI, we have the limited memory AI, we have the theory of mind and self-aware AI, right? So these are the 4 main types of AI. And if let's take a deep dive into each one of these different types of artificial intelligence, right? And see what makes it up, what are the features, what are the characteristics, and how do we identify one from the other, right? Now, the basic one, the most common one, is the reactive AI, right? Now, the reactive AI is the most basic type of AI there is, right? And it is a reactive system. We train these machines to react to certain inputs, right? They do not have a memory, so they don't store data. But what they do is they react to an environment. An example are spam filters, right? They take an input and they react to that input. Game playing machines, right? Recommendation systems, right? When you are on Jumia and you select something and they say people who liked this product or people who bought this product also bought this product, right? People who bought Milo also bought peak milk, for instance, right? So that's a reactive machine learning or reactive artificial intelligence. React. Oh, this person bought Milo. Let's recommend peak. This person bought this. Let's recommend this to him. Oh, a message comes in. It looks at the content of that message and it decides, oh, this is a spam message or this is not a spam. So it goes to your inbox. They are reactive in nature. Game playing AIs, they react, they take a move, you move, and they react to get the best possible outcome, right? So the main thing to know is they react and they do not have memory of their own. Now, the next type of artificial intelligence is the limited memory AI, right? Now, with the limited memory AI, it has limited amount of memory, right? So it has the ability to store previous data, which means it is able to learn from past mistakes or past tasks. An example is self-driving cars, right? They are able to study the data. They have a certain amount of memory, so they are able to know what to do beyond just reacting to their environment. Self-walking robots, they study their environment, and once they have a view of that environment, they are able to store this data. Now, once they have this data stored, it improves their understanding of the entire field. Now, the next 2 types of artificial intelligence are mainly theoretical, right, which is the theory of mind. And this involves having artificial intelligence that can interpret thoughts, that can interpret emotions, right? Think of it like communicating with ChatGPT. Only it's able to look at you, it's able to understand your thoughts, it's able to understand your emotions. You know, we've watched movies where you see robots try to, oh, you look sad. What is happening? What is wrong? You look sad. So we have these machines that are able to understand human emotions just the way you are when you are conversing with a friend. You know, you are able to study the environment, to react to their emotions. You are able to look at a friend and know that, oh, this person is angry. oh, this person is sad, this person is happy, just from their expressions and the way they speak. So the goal is having these machines that can understand these emotions, study these emotions, interpret these emotions, understand the mental states of people and animals as well, so they can better interact with people. Right? Now, because they are able to understand these emotions and these mental states, they are able to effectively and more precisely interact with people and their environment. And that makes them much better help because they can see you, they can hear you, they can understand your mental state, they can understand your emotions, so they are able to console you when you are sad, they are able to rejoice with you when you are happy, and so on and so forth. And the final type of AI is the self-aware AI, which is also theoretical, right? And from the name, it's quite explanatory. The AI is self-aware, right? And it's not, it sounds exactly as it is. We program these machines to, to not just be able to understand our own emotions, but to have an understanding of its own self and its own place in the world. You know, each one of us have our own place in the world. We have our role to play in making the world a better place. With a self-aware AI, this artificial intelligence system is able to understand its own place in the world, right? So how do I communicate? How do I interact with every other piece of within the world? And what is my contribution to the world? So we have this AI with this ability, although it's currently theoretical, but it's the goal at the end of the day. That's what we are trying to achieve, right, with AI. Now, this is like the first part of the class, which talks about the different types of AI. So whatever type of AI that we have today, whether it's recommendation engine, recommendation systems we find in e-commerce platforms and news channels to recommend products and news to us, even social media recommending posts and content to you based on your interest, or is a spam classification or a fraud detection that is being employed by financial institutions, banks, and the rest to detect fraudulent activities on their systems, to detect fraudulent activities on their networks, whether it's employing this artificial intelligence for threat detection and incident response in terms of data breaches and cybersecurity. We use in implementing these AI systems, you know, in cybersecurity to effectively filter and figure out threats even before they occur, and should they occur, to use AI to come up with incident response. How do we respond to this? Whether it's used in computer vision, in medical health, in medical practice, to kind of like identify cancerous cells even before they become well pronounced and stuff like that. They all fall in one or two of these types of AI, and mostly either reactive or limited memory AI. Now, the second part of this program talks about algorithms in AI. If we go back to the broader definition of AI, we said it's a branch of computer science, right, that deals with the development of this intelligence system, right? And when we talk about computer science, we're talking about coding, we're talking about algorithms, we're talking about maths and the rest, right? What is an algorithm, right? Because this AI, they are not just systems on their own. When you think of it, they are a series of mathematical equations, algorithms that have been put in place to either react or to save memory and make better decisions. So what is an algorithm, right? An algorithm, simply put, is a set of instructions followed in calculations or other operations. right? A detailed, unambiguous set of instructions, right? By detailed, it means it is very precise. By unambiguous, it means one thing does specifically what it is designed to do. We don't have one thing doing multiple things. If we say go left, you don't go right, you don't keep straight, you go left. You know, it is precise, it is detailed, it is unambiguous sets of instructions, right? And that is what an algorithm is. And a lot of these algorithms power these AI systems. A lot of these algorithms power these AI systems that we have, right? And what are the types of algorithms that we have, right? There are basically three types of algorithms that power this AI system. The first one is supervised learning algorithms. We have unsupervised learning algorithms, and then reinforcement learning algorithms. Right? These are the three types of algorithms that power on all of this. So whether you are building a regression system, whether it's an AI system to detect cancer cells, whether it's self-driving car, they all fall into one of these three categories. Now let's look at the first one, which is supervised learning. Right? Now, supervised learning is the most common and the most used category in machine learning, where we have a clearly defined input and output data. Right? So with supervised learning, think of it like training a kid, right? You are training a child, or you are training a child by doing something. So you give the child a set of inputs and an expected output. So the child learns that, okay, if this input produces this output, this input produces this output. So the next time this kid sees an input, he's able to map it to one or more of the outputs that he has already learned in the prior experience. Right? Now, even within this subfield, within this supervised learning, there are subcategories of supervised learning, right? And the two types of supervised learning are classification and regression, right? And with classification, as the name implies, we are trying to classify something. You know, you are trying to classify something as something. So think of our spam detection system, right? You have a spam detection system on your email servers. An email comes in, it classifies that email as either spam or not spam. The same goes in financial institutions where they use fraud detection. Similar technique. Is this transaction a fraudulent transaction or not a fraudulent transaction? There are times you might have made some transactions in the past and you get a message from your bank, or they call you and say, oh, your account is on hold because we suspect some fraudulent transaction. Sometimes you use an ATM in a different location and they put some hold, some temporary hold on your account, and they try to reach out to you. Can you confirm that you are the one making this transaction? Because they are classifying those transactions as either fraudulent or not fraudulent. Now, with regression, on the other hand, think of it more like we're trying to predict a continuous value, right? We're trying to predict.
Sorry,
Yes?
Shandon, can you hear me? Sorry
Yes,
for
I can hear
interrupting
you.
you, Shandon. Yeah, so on the chat, we'll have a few persons saying they can't hear you clearly. They're not very audible. So I don't know if you could up the tone of your voice a little bit. I think that would be most helpful.
Oh, okay, sure.
All right, thanks.
All right, all right. So like I was saying, regression, right? With regression, we have a system where we are trying to classify this time, not a single value, or not trying to classify, but we are trying to predict a continuous value, right? And by continuous value, we mean, think of it like numerical values. You want to predict what the temperature will be like tomorrow, right? So what will the temperature be like tomorrow, right? And the temperature tomorrow can be 35 degrees. The temperature can be 35.01 degree. It can be 35.7 degrees. And so the possibilities basically are endless, right? And because of that, we are trying to regress to figure out the best way to get a value as close as possible to the actual value. And I hope with that, we are able to understand supervised learning, classification, as well as regression. What are some of the specific algorithms that power this supervised learning, right? Now, some of those algorithms are decision tree. You know, we have decision trees, we have random forests, we have support vector machines, we have naive Bayes, we have linear regressions, we have logistic regression, right? So a decision tree is, as the name implies, a tree-based structure for decision making. You know, if you are familiar with tree-based system, basically you start from the root node and you ask a series of binary questions, yes or no. Say we want to classify whether an employee will come to work early or will come to work late tomorrow, right? And we ask, did the employee wake up early? Yes or no? Was there traffic? Yes or no? And did the employee got the cab on time? Yes or no? So it follows this yes or no pattern. And we have this process where, oh, did the employee wake up early? Yes. Was there traffic? No. Did he got cab on time? Yes. So he will be at work early. Did he wake up early? No. Was there traffic? Yes. Did he get cab on time? No. So we classify that, or we predict he will come in late. Now, with that being said, we'll look at random forest, which is from our concept and understanding of forest, right? A forest is a collection of multiple trees, right? So a forest is an ensemble model, and by ensemble, we mean like a collection of more than one value, right? So we have multiple trees, right? Multiple trees together to form a single model. So we just explained how the tree works, but imagine where you have multiple trees making decisions, and then we kind of like aggregate their decisions at the end. That is how a random forest classifier or regressor works. The support vector machines kind of like plot our data on an n-dimensional space. So this n-dimensional space can be two-dimensional space, three-dimensional space, four-dimensional space, and so on. And it kind of creates these multiple decision trees, separate these classes. So separate these classes, and they are commonly used for classification because once it plots this data on an n-dimensional space, it tries to separate them from each other, you know, separate them into distinct classes. So they are mostly used for classification problem. Now, another type is the naive Bayes, which is a probabilistic classifier. It uses conditional probability, and it is naive because by default, it assumes the fact that what do we call them? These events are independent, right? So The reason is naive. It's based on the naive Bayes theorem, and one feature doesn't affect the other. That's the basic belief, and that's why we call it naive, because it just believes that all of the events are independent. You know, waking up early does not affect his going to work early, or traffic doesn't affect going to work on time, doesn't affect going to work early. Naive Bayes assumes that each of these events are independent. Linear regression is the most common type of regression, where in school, I think in school we've played this around in secondary school days. But back then we used to call them, line of best fit. So the whole idea behind the line of best fit is really rooted in linear regression, right? And we have the line of best fit, and at other places we have things like ordinary least squares, which are all types of linear regression. And then the logistic regression is also a type of classification where it's kind of like predicts the value using binary value, either 0 or 1, to estimate a set of independent variables, right? So the output of a logistic regression model is either 1 or 0, yes or 1. And so one good example of application of logistic regression would be a spam filter. So is this a spam or not? Is this a fraud or not? And these are the major or the main types of algorithms when we talk about supervised learning. The second type of learning we will be looking at is the unsupervised learning, right? And by default, the unsupervised learning is going to sound like the opposite of supervised, right? And if in supervised learning, we have a labeled data where we have our input and output. With unsupervised, our data is not labeled, right? So we have a set of inputs, but we do not have an output, right? So how do we know which step to take, given that we just have these inputs and no output, right? So the major type of algorithm under the unsupervised learning is the clustering algorithm, right? And by definition, with clustering, we are trying to group some of these things together, right? We are trying to draw them together into one closely related value. So think of it like I'm bringing you a group of fruits, pineapples, and say watermelon, right? And I'm not telling you which is which. I'm just giving you these fruits. And I say, learn from them. You can then decide to say, okay, I am going to filter all the watermelons. I'm going to draw them to one side. And then I'm going to sort out all the mangoes to one side. Then I'm going to sort out all the bananas in one side. What you are doing effectively is called clustering, right? You create these clusters. That's because you do not have an output, a labeled output. So you create these clusters based on closely related values. And so you have these clusters, and then you figure out the features between these clusters. How do we go about them, right? So what are the algorithms that are used for clustering, right? The most common ones are the k-means clustering and the Gaussian mixture model, right? So k-means clustering, which is like the most popular, is creating series of clusters, right? Creating k clusters, right? So how many clusters do we have? We specify a predefined clusters, right? by selecting centroids. So what are centroids? It's like the middle value, right? So if we go back to our fruits, we have mangoes, we have bananas, and we have avocados, for instance, right? So we want to take their features of, let's say, pineapple, watermelon, and mangoes, right? And we know mangoes are smaller and they do have seeds, large seeds. Just one large seeds. Pineapples do not have seeds. Watermelon have lots of seeds, right? So, and then the size, mango is smaller, pineapple is medium, watermelon is bigger. So let's say we have these two features. What we are going to do is we are going to kind of like plot this on a plane. Let me use a plane as an example. We have this plane. What is going to happen is we are going to look at it. We say, oh, those that have one seed and are small come to this side. Those that have no seed and are medium on the other side. Those that have lots of seed and are large come to this side, right? So the centroid is like the middle point for each of these clusters. From the word center, centroid, the middle point for each of these clusters. So think of it like the rallying point, the muster point, where all the points within that particular cluster gather around. Right? So Gaussian mixture is also another type of model for k-means, but they all do effectively the same thing, clustering. The only difference is it depends on the type of data that you want to cluster, right? And these are by no means all the type of clustering. There are several other clustering techniques, DB scan. So if you want to cluster, location points, the way you compute the distance is different. You use the great circle. Who are familiar with geography will know how to distance between 2 points in a map. So, right, the way you compute distance between 2 points on a map is not the same way you compute distance between 2 points on a two-dimensional plane, So, but that's the basic idea behind clustering, right? Now, on the side, another type of this will be neural networks, right? So what are neural networks? Neural networks are algorithms, right, that are designed to mimic the human brain, right? So for those who are familiar with biology, the human brain has all these neurons, perceptrons, and the rest. So the neural networks are designed to work the way the human brain works. So you have lots of neurons, you have lots of perceptrons, so you have multiple inputs, taking in inputs, processing this data and giving you a result. The last type of algorithm we'll be looking at today is the reinforcement learning, right? And the reinforcement learning, as the name implies, it's reinforcing, right? You are reinforcing a particular action. There is something you are reinforcing, right? Something is happening and you are reinforcing that process. Hence, reinforcement learning, right? So this uses what we call a reward feedback loop, right? So it works by taking feedbacks from the results of action. So you take an action and then a feedback is provided based on the action you are taking, right? And so this is typically in the form of a reward, right? So there are basically two parts of reinforcement learning algorithm, right? The agent performs the action, and then there is the environment in which the action is performed. So the cycle begins when the environment has a state, right? So we have a signal and we send a signal to the agent, right? So from that signal, the agent then performs that action. Now, once that action is completed, the environment now sends a reward to the signal, informing it of what has happened, right? So the agent can update. So think of it like a child learning, right? But it's learning effectively by trial and error. So think of it like trying to ride a bike. And the child first picks up the bike and pushes it, and then you say, good, next we want you to climb it. Maybe he first climbs it facing backwards, and then you tell it, no, and then he facing backwards, and then you send a feedback to the kid. You say, no, you face this direction, right? And so the kid repeats the same action, but this time taking into account the feedback you have provided. So it turns its location, it turns its position to face the right location. So it climbs and it tries to ride the bike, but he falls. Then you give him a feedback again, and it keeps this process keeps continuing in a loop. It tries, and once it fails, a feedback is provided. If it succeeds, a reward is offered. So it keeps on doing this process over and over until an end state is reached where the entire process is successfully completed. Now, one example of where reinforcement learning is used a lot is in rocket launchers. Last year, Elon Musk was able, Starlink, were able to launch a satellite in space and still grab it, right? So how did they train the system that did that? It's a series of reinforcement learning. How do you land this rocket on the moon? You try different techniques, and each one is either fail or succeed, and you keep on trying over and over. Oh, I tilted it to the right too much, and so it collapsed. So this time you tilt it to the left a bit. You keep trying this process over and over until you hit a state where the end result is successful. You are able to hit a successful output. Right? Now, under reinforcement, under reinforcement learning, we have a policy, we have a model, and we have the value, right? So the policy defines the approach, the approach the agent takes to determine the next action taken by the agent. So your policy is, how do we approach this challenge? So we want to land a rocket on the moon. So we want the rocket to go in at 90 degrees. So that's the approach. So it goes in at 90 degrees and tries to land on the moon. Maybe gravity and everything there is different from Earth. So once it gets there, that approach that it takes to determine the next action is what we call the policy. The model is the situation and dynamics of the environment, right? So we take the situation and dynamic of the environment. We try to model the situation of the moon, since we want to land a rocket on the moon. So we try to create the model based on the condition the rocket is going to face, right? And the value is the expected long-term result, right? So, and you should note that this value is different from the reward, right? So the value is the long-term result. So what is the end value of this? Now, rewards are like what we give the model as, oh, you tried, to next time from this place, take a different direction. And so we keep on doing this process over and over until we are able to hit the expected value, which is the long-term result. And with that, we have come to the end of this presentation today. If there are any questions, I think we can take them now. And yeah, so I'll hand over back to David.
Awesome. Awesome. Thank you so much for that comprehensive lecture, Shandon. I know that a lot of the participants today actually learned a lot, although it's kind of filled with a lot of jargons. And by jargons, I mean like technical terms. But
Yeah, I was just going through the charts and I saw someone saying mango, familiar word. Like, yeah,
oh yeah,
like that. Yeah.
yeah, I was the one. But yeah, trust me, there is no one that would have done a better job in breaking this whole subject down than Shandon, right? And then I think I would just like to shed a little bit of light on one particular algorithm, which is reinforcement learning. Let me just add a little bit to that. So when it comes to reinforcement learning, I would like to let you guys know that even humans, we actually learn through reinforcement learning. And I'll explain that using what psychologists usually say. So psychologists say that humans, we usually run away from pain and more to what gives us pleasure, right? And it's about the same thing with your dog. So if you go online and check videos on how to train a dog, right? With what Shandon explained, the dog is like the agent in this case, right? So let's say, for example, you want your dog to sit and then you ask it to sit, the dog doesn't sit. Let's say you have like biscuit or cookies that you're giving it. You ask it to sit, it doesn't sit. I mean, your dog doesn't understand English, right? So you ask it to sit, it doesn't sit, you don't give it anything. And then let's say you ask it to sit by like pushing the butt down or something, and then the dog sits, you give it biscuits. By the time you do that like 3 or less like 10 times, over time, the dog would kind of match biscuits, which is the reward, to it sitting down. That when you say sit, or maybe you have like a sign language that you do for the dog, or like you sign the dog or something, and the dog sits, the dog gets used to the fact that, okay, whenever it sits, it gets a reward. And then it gets used to that enough that even when there's no biscuit or cookie for that dog, if you ask it to sit or you show that particular sign that you use in training the dog would automatically sit down. Back to something like humans, a lot of us when we're little, you have children when they see fire for the first time from a candle or something, they always want to touch it, right? I think during children that are born during the 90s, I think most of them, our parents would be like, allow me to touch on when the fire burn and you go learn, that kind of a thing, right? Which by the time the child touched that, the candle, like the flame from the candle or something, right, you would notice that by the time the child feels that hot, that burn, next time you don't have to tell the child not to touch the candle or something like that. The child automatically learns that he or she is not supposed to play with fire, right? Same thing with, let's say, for example, you ask your child, go and read the book. Maybe after reading, you can play video game or I'll buy you ice cream or so whatever. So over time, the child would then associate reading or whatever it is to reward, that even without you giving the child ice cream or asking to go and play a game or whatever, the child automatically builds a behavior or becomes addicted. Should I use the word addicted? Or let's just say used to the idea of reading and all of those things. So that's another way of seeing reinforcement learning. Yeah, outside of the agents, reward and policies and all of those things.
Yeah, another example would be when we were in school back in the days, they used to say, if you get first position, we'll buy you a bicycle. And so that the goal, so the goal was to get first position. And you do your first test and it comes out not very good. And you're like, okay, they tell you you have to sit up. right? So after the first series of first tests, it wasn't very good. They say, okay, you have to sit up. And back then, if you used to read once a week, or you used to read only when you hear there is test tomorrow or there's exams next week, then you have to sit up to try to read. So that's the feedback loop. You did a test, you know, the goal was to get first position, and you were going to classes, but you weren't reading, right? So the feedback was you need to read. And so the first test came, your performance weren't very good. So they say, read harder. We went back and read harder. And during the second test, your performance improved. And then they tell you, okay, you need to read harder again. And so during exams, you read even harder and your performance becomes better. And maybe you didn't end up with first position. And they say, okay, next year, you try it again. If you get first, we buy you a bicycle. And so from the experience you've learned in this year, you know that, okay, I need to read harder by default. So you have a better grade in the first test, and you still keep reading again. So the process keeps reinforcing itself. And before you know it, even when you don't have tests or assignments or exams, you find out that on your own, you are reading your books. And that's reinforcement learning also.
Awesome, awesome, awesome. So I think now we would leave open room for questions, and also for those asking about the attendance sheet, the attendance is live. So log into your Candleweb account, just as always. Go to the task section, and then you would be able to see the attendance sheet. And I think you guys already go between, but let me just reiterate. So you see the attendance. If you're on LinkedIn, I don't know if it's LinkedIn or post that was uploaded or Twitter, but whichever one is there, go there, like, you post, and then comment. Then take a link to your comment and then share it when filling the attendance so that we'll be sure that you attended this course. And as I said, please do like, comment on all of those things. And if you know anyone else that would benefit from those courses, feel free to mention them. The more the merrier. So we're going to open the room now for questions. We're going to take 3 questions, and then that will be it. So if you have a question, just indicate by raising your hand and we'll have you unmuted. For those, while we're waiting for those who want to have questions to indicate, for those of you who had network challenges, we're going to be having this video uploaded to our YouTube channel much later, so you can watch. Feel free to go to YouTube, search for Candleweb, or better still, subscribe to the channel so you'd always get notified when there's a new lecture video that has been uploaded. So I don't know if anyone have any questions before we end today's lecture. Anything you didn't really understand, or maybe something you would need Shandon to shed a little bit of light on.
All right, I'll go first. Hi, Shandon. Good evening. I'm Isaac Wilson, and I'm the CM of Candleweb. My question is about Aware AI. I was kind of distracted at that point though, because I kind of put my mind on it, but I had to attend to something. On the Aware AI, I didn't really get that part, and I was also thinking something about AI being aware. Then my mind kind of deviated to AI consciousness. So my mind kind of deviated at that point, but I would like if you can explain that part again. Thank you.
Okay. Are we taking the question one by one? We're just taking all, and then I address them once of all.
We usually take the questions one by one. If anyone has a question, they could just indicate by raising up their hands and we'll unmute them.
All right. So self-aware AI, right? So basically, the AI is self-aware. And by self-aware, the word itself is a bit self-explanatory, right? But the AI as an agent or as an entity is aware of its own self in the universe, right? So each of us have a role to play in this world to make the world a better place. We have our place, we have our role to play. Um, all the animals, everything works together in unison within the entire ecosystem, the entire world. Now, the AI is self-aware AI, is now aware of its own role in the universe, right? So how do I interact with humans, with animals, with nature? How do I make the world a better place? How do I make myself as an AI? So the AI is now thinking these questions, right? How do I interact better with humans? How do I interact better with animals? How do I interact better with the ecosystem around me? What is my role in this ecosystem, right? There's this movie, I think it's called Bad Robot or something like that, where the AI was stuck on a remote island. And in the end, the AI robot was able to communicate with all the animals. He was able to help some of the birds with their migration issues. He was able to build a shelter for all the animals to shield them from the coming winter. So he was able to find its place in the world because he was self-aware, didn't go about hurting other animals or trying to assert dominance over every other species. It realized its own place in the society, its own role to play, and whether it's helping one animal or making the world a better place. That's the goal, right? So with self-aware AI, the AI is able to think, what is my role in this world? How do I make the world a better place? Right? So it's able to have this human level consciousness to think, to make some of these decisions without human intervention and without much hazard to the world, the ecosystem, and everything at large. I hope that answers your question.
Yeah, that answered my question very well. Thanks. Glad you attended to it. Darrell, do we have any? I just want a quick follow-up. Do we have any AI system that is currently self-aware or that is working towards achieving this?
Yes, so the goal, this is the final goal, right? So all the AI systems at the end of the day, ChatGPT and the rest, the goal is to create a system, an AI system like this, right? But currently it's theoretical, but with the rapid growth in computing power and so many other advances, quantum computing and the rest, which will exponentially increase computing power, this should be achieved in, I think, at least, let me be optimistic, in our lifetime, we should be able to have something like this, a self-aware AI, and that is able to find its place in the society and think consciously, you know. There's so much debate about intelligence as it is, you know. Some people are of the opinion if it is artificial, then it's not intelligent. But then that's just philosophical. People are saying, oh, intelligence is intelligence. Some are saying, no, if it is artificial, then it is not intelligent. But at that level, it's just philosophical. But the goal is at the end of the day to have this system that is conscious and self-aware.
Yeah, thank you very much, Shanding.
Awesome.
I appreciate this. And I hope we'll also be able to see it in our lifetime. Thanks.
Awesome. Also to add a little bit to what Shandon said, just as he said, it's theoretical. So this is more like a debate in the AI community. Some persons like Jeffrey Houston, I don't know if it's Houston, but I know there's a Jeffrey in his name though. I think he's called the godfather of AI. Personally, he believes that even our current AI systems are aware, they are conscious. But then again, there is no single definition for consciousness because even humans ourselves, we still don't understand what consciousness truly is.
Yeah, true.
Yeah, so until we're able to have a single definition or understanding of what consciousness is, it's kind of going to be still theoretical to be able to decide or determine if AI systems are aware because if you're having a chat with ChatGPT and all of those things, I mean, you can remember your name, you can remember a lot of stuff. So the question is that what consciousness is? So yeah, it's still kind of theoretical. So you can actually argue that current AI systems like ChatGPT are aware. You can still argue that it isn't. There's no winner or loser in this until we've been able to really determine what consciousness is. So I noticed.
Thanks for adding that, David.
Yeah, you're welcome. So I noticed. I think was it Solomon or someone that raised their hand up that they have a question. So I think because of time, we're going to take just one last question. So Solomon. So if you still have a question, please indicate so you can. Yeah.
Good evening, sir.
Yeah, good evening, Solomon.
How are you, sir?
I'm doing great. How about you?
I'm fine, sir. The last class we had, the last day in class, you made us listen to the lecturer, and we stopped taking notes actually because you promised that after the lectures, handouts will be sent to us, and we waited. It was not sent, and today again I didn't follow I didn't write throughout the class. I was busy listening to the lecturer with the hope that after the class we can get handouts. So I don't know. As promised, please, we actually need the first handout and the second handout, sir.
That's
Okay,
not going to be a problem.
Solomon, yeah, thanks. It's going to be shared with you. For the first lecturer, he just sent in his lecture notes and would make that available with you during the weekend. And for Shanding's class also would make that available. So you'd get that within the weekend, Solomon. So
Okay,
does
thank you very
anyone
much,
have
sir.
any question with relation to the class?
Sorry, to add to what Isaac said, Solomon, are you following us are you subscribed to the channel on YouTube? To Candleweb channel on YouTube? If you're not, subscribe to that so that you can always get notified when we upload the lecture videos so that if you have to, maybe you still don't comprehend something from the lecture material, you can always refer back to the video and then you would be able to follow up and combine both the video and then the lecture material and have a comprehensive understanding of the lecture. So I see John Yakubu has his hand up. Isaac, please unmute John so he can ask his question. I think that would be the last question that we would be taking for this class.
Yeah, John, you can unmute yourself. You have the access.
Yeah, good day, everybody. Oh.
Good day, brother.
Hello,
Good
can you hear me? Good evening, thank you. Yeah, concerning this self-awareness AI, I hope you can hear me.
Yes, we can.
Okay. I don't know whether my question is a bit early, but I think the self-awareness AI happens to be, according to the lecture, it has a way of adapting to the environment it finds itself, trying to see how it relates with whatever that is available, either human or animal. And the aim is to make the world a better place and find a ground for interacting whatever species it finds available, right?
Yes, correct.
Okay. You know, let me talk as someone that like watching AI movies a lot. Most of the robot world we see in movies happens to be with this particular level of AI who happens to be smart and later they fail, they outsmart their, let me say, their creators or their inventors. And then they fail when they say peace. The language of peace to them means just annihilate the word. But you understand what I'm saying? Like
Yeah.
just to clear human beings off the earth because humans are pollution. So my question is, like I said, I don't know whether it's the end. Don't we think that later in the future, this self-awareness AI, don't you think they may possibly develop that kind of knowledge that they may think humans are actually threat? For sure, we are a threat to our environment because we make it, we destroy it. So don't you think they can grow that consciousness and try to like get to human and just wipe humanity off the earth?
That's a
Um,
wonderful question.
yeah, what a very wonderful question. So, first of all, this is like the prehistoric period where fire was discovered for us, right? Where fire was discovered, right?
Yeah.
The people back then, they could have, no, fire can burn our house and maybe burn some few people, so we are not going to use fire again, but they didn't
Yeah.
think that. And we also shouldn't think that when it comes to AI. But the second thing is there is a big voice, people are being proactive about ethics. And I think Candleweb, part of this series, there is the ethics session coming in, right? Where
Oh,
where we'll be looking at it's not just sufficient to create this AI system. Let's come up with ethics. How do we ethically create this system, right? Because the truth of the matter is,
yeah.
we as humans, we are biased. And if we are
Yeah.
creating these AI systems with our data from our biased mindset, it is possible to have our own bias spill over to this AI, and then we end up with systems like this, right? But then when we incorporate ethics into this development, ethical practices, right? We see ethical practices in law. We see ethical practices in medicine. We see ethical practices in almost every discipline. So let's bring these ethical practices into AI so that we build transparent AI. Before AI gets to a certain place, if you want to go to certain place, you see people documenting the type of data they collected, how they collected the data. If in academia today, people are trying to use these AI systems, but there is the people are like, oh, don't use AI system in academia. So there are those that are like, okay, we use AI in this place to do this, So they are leveraging, they are speaking out. We have to be conscious of the fact that, yes, this can go wrong, this can go right. It's like with fire, right? If you play with fire too much, you use it to cook your food, to do a lot of things, but you can still use it to destroy a lot. So the good sides of AI is so good, is so numerous that we can't just let the fear of it going bad stop us from exploring it. All we can do is to incorporate ethics so that as we build these AI systems, we build AI systems that are transparent, that are ethical, and void of biases that might end up resulting in systems where the AI turns on itself. Because when we talk about consciousness, right, we talk about the AI being in sync with its environment, its nature, right? And we as human beings, we are also part of the nature. So if we have an AI that is not in sync with us, it means it's not in sync with nature because we are also part of nature. So we have to incorporate ethical AI development from the very beginning when creating the AI systems.
Awesome.
All
And,
right.
to
Thank
add a
you.
little bit to what Shandon said, right? Everything literally is around the data that these AI systems are trained on, although we can't exactly rely on that anymore because now I think that was last month or last 2 months, I was reading a research paper that was published by, I think, Microsoft, where AI systems now are able to generate synthetic data that they can use to train themselves to improve. But I think we're a resilient species. So for anything to take us out, whether it's AI or any other thing, I think they would actually find it quite difficult. And I think we're already taking precautionary measures in that regard. I think that's one of the reasons why Elon, for example, amongst other persons or companies, why Elon's Neuralink, they have the Neuralink chip, which you can put in your, which is usually inserted in the human brain, which is supposed to, I think the long-term plan is for humans to be able to interface with AI systems, right? So that we can be able to expand our neural pathways because that's literally how you learn. The more you learn, the more your brain has more, creates more neural pathways and all of that. So we're literally in the era of intelligence, right? So long as humanity keeps working towards that, and then we also have things like explainable AI and all of those things. But most of these things, we'll be talking about them during the ethics class or lecture. So that way we'll be able to help everyone understand that yeah, human extinction might not or would probably not happen anytime soon. And as I said, we're a very resilient species. I mean, a lot of biological viruses have come and they've gone and we're still here. So I think it's going to be the same thing with AI if at all such a thing should happen.
All right. Thank you very much. I think that will be all
Awesome.
for now.
Awesome. Thank you for that question. So thank you everyone for tuning in for today's lectures. We'll be having another one by next week, Tuesday. We'll be announcing the time and all of that. And then for those of you who are not following Candleweb yet on Twitter or LinkedIn, please do make sure to follow so you'd always see what we're doing and all of that. We're still going to have other courses aside from those one. Probably even have an AI advanced course where we'll then start giving them like practical examples and teaching of tools, how you can use some AI tools that would help you be a lot more productive in your work or whatever it is you do and all of that. So yeah, thank you everyone and do have a wonderful evening. I'll be seeing you guys in the WhatsApp group. And yeah, please make sure you follow Shandon. We've mentioned him on LinkedIn. Shandon shares a lot of wonderful content around artificial intelligence and all of that. So if you want to know more about AI, Shandon is one of the persons to follow. And yes, if you do have AI projects you want to build as well and all of that, that's what his company does. And yeah, I can vouch that they do a really great job. So thank you everyone for tuning in. I'll see you guys on the WhatsApp group. Take care everyone and enjoy the rest of your evening.
Thanks, David, and thanks everybody. Thank you, Shandon, for the amazing lecture and for the answers. We do appreciate you. Take care of yourselves, everyone, and have a good night's rest.
All right, thanks everyone. Cheers.
Awesome.
So please don't forget to sign the attendance for today. Go to our platform, enter your Candleweb accounts. When you open the platform, go to platform tags, and you see the attendance today. Like David stated, just click on it. Then you can drop your comments, like and repost. Then copy the link to your comments and paste it on the provided field on our platform, and also fill the attendance form, and we'll mark you present for the second attendance. So take care of yourselves. The group would be open for further assistance and questions before it goes closed for tonight. And the attendance would also be closing by 10 p.m. tonight. So take care of yourselves and good night.
Okay, all right. Thank you, sir, for today. Please, good evening again, once again to everyone. Please, would you help us with the recording this weekend so we can follow up, especially for those of us that missed Tuesday class?
Yes, it will be uploaded on our YouTube channel. The first and second lecture, that's Tuesday and today's, would be on YouTube on Sunday morning, and we'll also be sharing your first weekly quiz. So expect that on Sunday.
All right, thank you, sir.
All right, John. All right, you're welcome. John would look into the rewards claiming and would fix that. So just sign the attendance for today. Would verify it manually, then we fix that. Tuesday's reward should be able to be claimed. And if you have issues with that, we'd also look into it. So take care. You're welcome, John.